Have you ever just stopped and wondered how the complex, high-tech stuff we use every single day is made so perfectly? From the phone in your hand to a massive jet engine. It all boils down to this relentless, almost obsessive quest for perfection. And today, we're going to dive into the hidden world of measurement that makes it all happen.
So let's just start with that huge question. How do you manufacture perfection? I mean, it's one thing to design some amazing, complex part on a computer screen. It's a whole other ballgame to actually make millions of them, where every single one is basically a perfect clone of the last, right down to a microscopic level. The answer, it turns out, isn't just about better machines, it's about better measurement.
And nowhere is this more critical than in an industry like aerospace. I mean, just look at these components. They're incredibly intricate, unbelievably complex, and they have to operate under insane amounts of stress. For parts like these, close enough just doesn't cut it. Quality isn't just a nice-to-have, it's directly tied to safety. There is literally zero room for error. So how on earth do they pull it off?
Well, to really get it, we need to back up a little and look at the fundamental science behind everything. You can think of it as the ultimate rule book that governs every single measurement we make.
That field is called metrology. It's the science of measurement, and honestly, it's the invisible foundation of our entire modern world. It's how we all agree on what a millimeter is, or a kilogram, or even a second. Without that shared understanding, things like global trade and manufacturing would just fall apart. Now, what's so cool is that you can break this huge, complex field down into three pretty simple ideas. First, you have to define the unit itself. You have to ask, what is a millimeter, really? Second, you have to bring that definition into the real world. How do we actually make a ruler that we know is accurate? And third, and this one is absolutely crucial, you need traceability. You need a system to make sure that my ruler, in my factory, is measuring the exact same millimeter as your ruler in a factory on the other side of the planet.
And this pyramid shows that idea perfectly. It's literally called the traceability pyramid. Think of it like a family tree, but for measurement. Way up at the top, you've got the one single international standard, the great-grandparent of all measurements. That standard is then used to check national standards, which check the tools in special labs, which then check the actual instruments being used on the factory floor. It's this beautiful, unbroken chain that guarantees we're all playing by the same rules.
Okay, so we've got the science down, but how do you take all this high-level theory and actually apply it in a busy, fast-paced factory? For that, you need a very special kind of tool. You need the ultimate measuring machine.
And here it is, folks, meet the hero of our story, the Coordinate Measuring Machine, or CMM for short. This is the amazing machine that brings all that high-level metrology right down to the factory floor. It uses this super-sensitive little probe to gently touch hundreds, sometimes thousands, of points on a part's surface. And in doing so, it creates this perfect 3D digital map of its exact dimensions with just mind-blowing accuracy.
Now you gotta understand, before the CMM came along, this was all done by hand. It was slow, tedious, and of course, full of human error. But these machines, they were a total game changer. They completely slashed measurement time, they sent efficiency through the roof, and they gave engineers a level of precision quality control they could have only dreamed up before. They quickly became essential for industries like auto and aerospace.
But this creates a really fascinating new problem, right? If the CMM is your ultimate source of truth, your ruler of rulers, then how do you check the checker?
And that's the million-dollar question. What happens if your hero machine has an off day? Tiny changes in temperature, little vibrations in the floor, or just simple wear and tear can cause its measurements to slowly drift. And an inaccurate CMM is actually worse than no CMM at all, because it's lying to you. It's giving you this false sense of security that everything's perfect when it's not.
So the solution comes from a field called Statistical Process Control, or SPC. And what you're looking at here is one of their key tools, an X-bar chart. Think of it like a heartbeat monitor for the machine. Each one of those dots is a measurement taken over time. And as long as all the dots stay between those two control lines, everything is stable, everything is in control. But the second a dot falls outside those lines, bam! That's an instant red flag that something has changed and needs to be looked at right now.
And this slide shows the really key innovation here. The old way, up at the top, was to stop the machine every once in a while for these big, infrequent checks. It was slow, it was inefficient, and you could make a ton of bad parts before you even realized there was a problem. The new method, on the bottom, was the breakthrough. build online diagnostics right into the machine's day-to-day cycle. It's like a constant automatic health check where the machine is always monitoring its own performance in real time.
So this real-time health check was a massive leap forward. But as the machines got smarter, they accidentally created a brand new problem. A giant flood of data that no human could possibly keep up with. A data tsunami, really. And this shows the huge bottleneck that process created. So a CMM would finish its measurement and just spit out this massive, unreadable text file of raw data. And some poor quality manager would have to manually find it, painstakingly type it all into a spreadsheet, try to analyze it, and then spend hours and hours writing up inspection reports. It was just incredibly slow, incredibly tedious, and a perfect recipe for mistakes. So, of course, the next revolution was to automate this entire data flow. Now, the second the CMM finishes a measurement, a little software agent instantly swoops in and grabs that raw data. It automatically cleans it up, standardizes everything into one universal format, and then zips it over to a central data warehouse, all ready for immediate analysis. No more spreadsheets, no more manual data entry. It just happens.
And the payoff? I mean, just look at these numbers. They are absolutely jaw-dropping. A data acquisition task that used to take a full hour of someone's time, it now takes less than 1 second, 0.7 seconds. And generating a full inspection report, a task that took 4 hours, now takes 0.9 seconds. This isn't just a small improvement, this is a complete reinvention of the whole process.
And this is what all that automation makes possible. Instead of being buried under mountains of raw data, quality managers now get these powerful, live dashboards. They can see trends happening in real time, they can monitor the stability of the entire factory at a glance, and they can dive deep into any potential issue with just a single click. It's data that's been transformed into instant, actionable insight. So, what does this all add up to? I mean, this whole evolution in measurement and data is about way more than just being efficient. It's actually the very foundation of the modern smart factory.
The impact here is just enormous. It means safer airplanes and more reliable products because the quality control is just on another level. It means less waste and lower costs for companies. It even helps speed up innovation because you can get feedback on new designs almost instantly. And yeah, most importantly, it provides the essential data backbone for what we all now call the smart factory.
And this quote just nails it, doesn't it? A smart factory isn't just about cool robots, it's about integrating digital automation into every single stage of production. And as we've just seen, you simply can't have an intelligent production system without intelligent, automated, and traceable measurement. It's the starting point for everything else. Which kind of leaves us with this one last fascinating question to chew on. We've gone from humans checking parts to machines checking parts, and now to machines checking themselves. So as that trend continues, what does quality control even look like in a future factory that runs completely on its own? It's a pretty wild thought, and it's a future that's being built as we speak, one perfect measurement at a time.